projects. In this video, we are going to explain about the project title Toxic Comment Detection in Online Discussions. Before diving into the execution, let me give you an overview of the project. Toxic comments in online discussions are harmful and include hate speech, harassment, threats, or insults aimed at people or groups. These comments make the online space hostile and unwelcoming, discouraging healthy conversations and causing emotional harm to those targeted. It's important to detect and address toxic comments to ensure online interactions are positive and inclusive. Traditional toxic comment detection methods like keyword based filtering, rule based systems, and machine learning classifiers struggle to capture nuanced toxicity, handle language complexity, and adapt to evolving forms of toxicity. They often require extensive manual effort and are vulnerable to evasion tactics, limiting their effectiveness in maintaining online safety. The project integrates exploratory data analysis EDA, data visualization, and machine learning algorithms including KNN, K nearest neighbor, XGBoost, ANN, artificial neural network, LSTM, long short term memory, and BiLSTM for toxic comment detection in online discussions. EDA and visualization aid in understanding the data set, while the diverse set of algorithms enhances the system's accuracy in identifying toxic comments. The project seeks to improve online discussions for all involved by automatically identifying toxic comments. This helps platforms create safer spaces, reduces moderators' workload, and ensures users have a more positive experience with less exposure to harmful content. Integrating Flask allows the creation of web interface for the toxic comment detection system. Users can easily submit comments and view results. Flask handles routing, requests, and template rendering, enhancing accessibility and usability. To implement this project, we need software and hardware requirements. Software requirements of the project are application in Xanaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, databases SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used. These are the algorithms built in the project, which are KNN, K nearest neighbor, ANN, artificial neural network, LSTM, long short term memory, BiLSTM, bidirectional long short term memory, XGBoost, extreme gradient boosting. We have built all these algorithms to compare the performance with different evaluation metrics like accuracy, precision, recall, and FN score. And here the XGBoost outperformed the other algorithms, and that is the reason we have deployed it in the front end. Now let us execute the project. To execute this project, first we need to open the code folder, which contains the project source code files. So here, this is the dataset folder. The dataset is split into test and train. Let us open the test file. So here we can see the parameters, ID, comment text. So here we can see the different comments, and these are the IDs. So this data set is used to evaluate the performance of the model. Now let us close this data. And here, this is the train file. Let us open this. So here we can see the different parameters: ID, comment text, toxic, severe toxic, obscene, threat, insult, and identity hate. So here these are the comments, and this data set is used to train the models. Now let us close this data set. And here, this is the model folder, which contains algorithm information, which will be loaded into the project code during runtime. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here, this is the model file, which contains algorithm information, which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And here, this is the test cases text document. Let us open this. So here, these are the test cases which we will use during the execution. Now close this. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. So if we are new users, we need to register first. So click on sign up link here. So here we need to enter all these details to register. But I have already registered, so click on sign in button. So here we need to enter the username and the password, which are static, and then click on submit button. We have logged in successfully and we are redirected to the prediction page. So here we need to enter the message in the text box, and after entering the message, the application will predict whether the entered message is toxic or not. So from the test cases, let us enter the message. So these are the test cases which I have showed you during the execution. So from here, I am selecting the first message. So copy this message and paste it here. So this is the message which we have entered. Now click on enter button. So here we can see the results for comment. So here we have the different scores for the toxicity. So the first one is toxic 1.0. So this score indicates a high certainty that the text is toxic. Toxicity generally refers to any form of language that is rude, disrespectful, or likely to make someone leave a conversation. Coming to the next one, which is severe toxic, which is 0.56. This score indicates a moderate certainty that the text is severely toxic. Severe toxicity is more intense and harmful than regular toxicity, often including highly aggressive, demeaning, or hateful speech. Coming to the next one, which is obscene, which is 0.49. This score indicates a moderate certainty that the text contains obscene language. Obscenity includes explicit language, vulgarities, and other forms of crude speech. Coming to the next one, which is threat 0.23. This score indicates a low to moderate certainty that the text contains threats. Threatening language includes statements that imply harm or violence towards someone. The next one is insult, which is 0.89. This score indicates a high certainty that the text contains insult. Insulting language is meant to demean or belittle someone. Identity hate, which is 0.96. This score indicates a high certainty that the text contains identity hate. Identity hate refers to speech that attacks someone based on characteristics such as race, gender, sexual orientation, religion, or other aspects of identity. The scores are typically on a scale from 0 to 1, where 0 means no likelihood and 1 means high likelihood. In this case, the text in question is very likely to be toxic, insulting, and contain identity hate, with some likelihood of being severely toxic and obscene, and a lower likelihood of containing threats. Now click on try again. Let us enter one more comment. So I'm entering the comment from the test cases itself. Copy this and paste it here. Now click on enter button. So here we can see the results for the comment. Toxic is 0.42, severe toxic is 0.54, obscene is 0.9, threat is 0.0. It means that the comment which we have entered does not contain any threat content. Coming to insult, which is 0.07, it means very less content is of insult. Identity hate is 0.29. So here we can see that the toxicity is very less in the comment which we have entered. Now click on try again. Let us enter some more comments. So I'm entering one more comment from the test cases itself. Copy this comment and paste it here. Now click on enter button. So here this is the result for the comment. So the toxic is 0.15, which is actually less. Severe toxic is 0.17. Obscene is 0.91. It means this score indicates a high certainty that the text contains obscene language. Obscenity includes explicit language, vulgarities, and other forms of crude speech. And threat is 0.0. So this score indicates a very low certainty that the text contains threat. It means that the text does not contain threat. Coming to insult, which is 0.11. So this score indicates a very low certainty that the text contains insult. Insulting language is meant to be demean or belittle someone. Identity hate is 0.84. So the scores are typically on a scale from 0 to 1, where 0 means no likelihood and 1 means high likelihood. In this case, the text question is very likely to be non-toxic, insulting, and contain identity hate, with some likelihood of being less severely toxic and obscene, and a lower likelihood of containing threats. Now click on try again. Let us enter one more comment. So I'm selecting the comment from the test cases itself, copy this and paste it here, and then click on enter button. So here we can see the result for the comment. Toxic is 0.62, severe toxic is 0.54, obscene is 0.99. It means that the comment contains the obscene language, and threat is 0.09, which is very less. Insult is 0.11. Identity hate is 0.71. So overall, the content of toxicity in the comment which we have provided is less. So in this way, we can enter more comments, and after entering the comments, the application will predict whether the entered comment is toxic or not. So now click on sign out link here. So the conclusion of the project highlights the model's effectiveness, acknowledges challenges, emphasizes the importance of combating online toxicity, suggests future research directions, and addresses ethical considerations.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.